Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the programming challenge, the Credit Card Fraudster. Let's get into it. I just arrested someone who is probably the most wanted credit card fraudster in Europe. She is a smart cyber criminal, always a step ahead of Interpol, and she kept unnoticed for years by never buying online, but buying goods with a different credit card every time and in different stores. My cyber analysts found out after collecting all evidences she hacked into one of the largest payment providers in Europe, reverse engineered the software present on the server, and partly corrupted the card number validation code to accept all her payments. The change enables acceptance of any transaction with a card number multiple of 123457, and the loon check digit is valid. I caught her because every year she bought a bouquet of flowers next to the same cemetery. While handcuffing her at the flower shop's exit, she said the flowers were for her lost father and today it is his death anniversary. She broke down in tears and she did some steps and threw something in the sewers. My female colleague conducted a search on her, but she couldn't find the card she used, only the receipt. And they give us a picture of the receipt here. Can you help me to recover the card number so that I can confirm with the flower merchant's bank the card number was used in that shop and is fraudulent? Hence, 1, loon algorithm, 2, flag format. Okay, first thing we start off here is they give us a credit card number that has 6 asterisks. So we need to guess what those 6 asterisks can be. And depending on what the full 16-digit credit card number is, it needs to be divisible by 1, 2, 3, 4, 5, 7, and it needs to pass the loon algorithm. So where do we start? Well, let's start by getting a for loop going of all the different 16-digit credit card numbers that, if passed into the loan algorithm or divided by 1, 2, 3, 4, 5, 7, could potentially be a credit card number. The way we're going to do that is just set up a simple for loop up here. And we'll do for I in range of 1, 2, 3, 4, 5, 6. And then we'll do +1 because we want to make sure we get the last number in the range of numbers. And then we're going to set our card equal to a format string of 543210. And then we're going to set the index in here to 6 decimal places. And that's what this serves to do right here. So instead of just going from a single digit of 0, we're going to go from 6 digits of 0 to 6 digits of 9. And I'll write it out here after I finish typing in the string here. So what this is going to do is it's going to go from, instead of 0 to 9999999, it'll actually be 2, 3, 4, 5, 6 to 1, 2, 3, 4, 5, 6, like that. But of course, maintaining the same prefix and suffix that we have going on that are statically defined in our receipt. Now, before we do the loon algorithm, we're going to go ahead and check to see if the number is divisible by 1, 2, 3, 4, 5, 7. And the easiest way we can go about doing that is if int card, because it's a string right now, so we need to convert it to an int in order to perform math operations on it, modulo 1, 2, 3, 4, 5, 7, like so, is equal to 0, because if it's equal to 0, that means there's no remainder, which means it is divisible by that number. And now we can go ahead and start working out what we're going to do for the loon algorithm. Now, this is how the loon algorithm works. So let's take whatever number comes out of here first. We'll do print card, and then we'll break. All right, this is our first valid number as far as being divisible by 1, 2, 3, 4, 5, 7. So now I'm going to go up top here and just kind of demonstrate how this loon algorithm will work. And you're going to start off with your number, of course, here. Let me copy that. And then underneath that, you're going to do a weight of 212121 all the way across until you get to the end of the number. Then what you do is you multiply each column together. So first off, we would do 5 times 2, which would be 10. 4 times 1 is 4, and so on and so forth. 3 times 2 is 6. 2 times 1 is 2. Now, our first number happened to be a double digit. If you multiply the two numbers together and you get double digits, well, instead of multiplying the two numbers together, you're going to add them together. So 10 would actually be a 7. And let's see if we can find another one in here like that. It doesn't look like there's another double digit in here for this example, but you get what I'm saying. So 5 times 2 is 10. 10 is double digits, so you add them together. And for any single digits, which is the rest of these pretty much, you're going to keep whatever the value is as a product. So 4 times 1 would just be 4. You wouldn't add them together. And you're just going to do that so on and so forth. So we're going to assign our weight a variable. Let's do weight equals, and then we'll put it into a string like so. And the reason we're putting it into a string is that when we loop through our credit card number, we can use the index that we are on with our credit card number as the same index we're going to be on with our weight. And now we're going to remove that break actually. And then we're going to also remove the print card here. We don't need that anymore. We're going to establish a product array, which is going to essentially hold our final result, which, would be whatever this is up here. And then we're going to do a new for loop. We're going to say for j in range of the length of the card. If the card at j times the weight at j is greater than 9, right? Because that would be double digits. Then we're going to do product.append card at j plus weight at j, like so. Now, this won't work on its own. We actually need to convert these to ints because remember, when we reference these characters, they're going to be strings and not integers. So we need to make sure to wrap all these in the integer conversion function. That way we're actually doing math operations on ints. And then we're just going to say else the same line, but we're going to do a multiply instead. So with that out of the way, we'll get our product. Now, one thing I forgot to mention with the Lund algorithm is that once you have all of these values, what you're going to do is add them all together. So you're going to want to do the sum of all these. And if the sum of those numbers ends in a resulting number whose final digit is a 0, then we know that passes the Lund algorithm. Okay, so keep that in mind. We have to make sure that the last digit is 0. Well, how do we do that? Well, we can just mod by 10, right? Because any number that's divisible by 10 ends in a 0. So we're going to say if sum of prod, right? Because this will take our array that we instantiated and add all the elements of it together. Mod 10 is equal to 0. Then we're going to print our card number, and we're going to break out the loop because we have the card number that we need. So we'll save that, and let's go ahead and run it. Oh, I'm actually outside of our inner for loop here. So let's tab that in, and let's rerun it. And we get our final credit card number down here. We'll copy that and put it in our flag format here. And submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.